Let's take a look at some examples for confidence intervals for proportions. In a recent survey of 150 households, 54 had central air conditioning. Find P hat and Q hat, where P hat is the proportion of households that have central air conditioning. Remember that P and Q and P hat and Q hat are representing proportions, percentages. So we're going to take the total number of households and the total number that have central air conditioning to find P hat. So P hat will be X divided by N, where X is the number that have the quality we want, in this case 54, and N is our total, 150. Let's use our calculator. 54 divided by 150, and we end up with 0.36 for P hat, 0.36. Q hat is 1 minus P hat, so 1 minus 0.36. Pulling up our calculator again, 1 minus 0.36 gives us 0.64 for Q hat. We have a formula here for our proportion, for our confidence interval, when NP is greater than or equal to 5 and NQ is greater than or equal to 5. What I want to point out from this formula is this part right here, this Z alpha over 2 times the square root of P hat Q hat over N. We call this the error bound for proportions. Your book abbreviates this as EBP. So if you come across EBP, it's the error bound for proportions. There's not a formula in Excel or Google that will calculate this easily. Excel does not contain a formula or an easy way to calculate confidence intervals for proportions. So we're going to use a template that's been created. A template in Excel really just is the formulas are already built in, and I'm giving you the sheet that has these formulas in them. You just have to input the values in the correct places. Here's our template that we'll be using. So essentially we're going to look at filling out B4, B5, and B6, ultimately. Often we don't know the size of our population, N, and we may know the sample proportion, and we may not. It really depends on the context of the problem. So sample proportion, P is P hat. I'm going to make that change right now. So P hat, we may know from the context of the problem, and we may not. If we do know P hat, we would go ahead and stick that here and get rid of the number of successes in the sample because we wouldn't know that. We've got our sample size N. We should be given our sample size every time. And we have our confidence level 0.95. So notice it's giving us a warning, fill in a gray cell above, and then it's got all these value things going on. This, notice, is a norm inverse function. So we're finding the Z alpha over 2 that is associated with that confidence level. The standard error is the square root part. The margin of error, this is our error bound for proportion. Different textbooks and different instructors use different words. There's not really a standard to this, unfortunately. So you may see other abbreviations coming up. And then the lower confidence limit and the upper confidence limit. So the number on the bottom, the number on the top. P minus the margin of error, P plus margin of error. I'm going to show you how to use this in an example. So let's skip this down into problem number 2. A sample of 500 nursing applications included 60 from men. Find the 90% confidence interval of the true proportion of men who applied to the nursing program. Some values to call out. We have a sample of 500, so N is 500, included 60 from men, that means X is 60, which means we can form P hat, and we're looking for the 90% confidence interval. So confidence level is 90%. Pulling up our template, we don't know the size of the population, we don't know P hat, we do know the number of successes. That was 60. Our sample size was 500, so let's change that. And our confidence level was 90%, so we'll change it to 0.90. And notice it calculates our sample proportion, so 60 divided by 500 will give us 0.12. It finds our critical value. We'll see this critical z-value several times when we work with these confidence intervals for proportions. We'll see some of the common critical values because we'll generally use 90%, 95%, or 99% confidence levels. And then the calculation of the standard error and then multiplying the two together. So if you were to do this by hand, this margin of error here, that 0.0239, that's the error bound for the proportions. And then we take the p-hat 0.12 and subtract 0.0239, we get 0.096, and then we add 0.12 to 0.0239, and we get 0.1439. So you can see how these are coming up to giving us our answers. And so you can see how the 0.12 p-hat plus or minus the margin of error will give us the confidence levels right there. This template does check to make sure that we have at least 5 successes and at least 5 failures. That's that n times p greater than or equal to 5 and n times q greater than or equal to 5, so it works out. And it makes for a really nice, quick calculation as long as we put in the information. The big picture behind this for us is the interpretation. So keep that in mind. You have to put the interval out there and then explain what that interval means. So let's model that. The first thing that I'm going to do is grab that image of the Excel template and stick it in my OneNote so that if you wanted to go back and look at it, you absolutely could. And so shrinking it down, I see my values here for my lower and upper confidence limits. So coming over here, writing out our answer, the true proportion of men who applied to the nursing program, we end up with the confidence interval here, 0.096 less than p less than 0.144. Remember, we're estimating the population proportion, so we want p in there. And then we would say we are 90% confident the true proportion of men who applied to the nursing program is between 9.6% and 14.4%. And that would be how we would answer that problem. Let's take a look at the next one. A survey of 1,721 people found that 15.9% of individuals purchased religious books at a used bookstore. Find the 95% confidence interval of the true proportion of people who purchase their religious books at a used bookstore. So we have a total number. There's our total number of the sample, N, 1721. This problem is different because instead of giving us X, the number of individuals who purchased the religious books, they actually give us P hat right here, 15.9%. So we are given the sample proportion. And then our confidence level here, that 95%, there's our confidence level. We only need 3 values, and we can go back to our template and put some information in. This is our template left over from the last problem. So we didn't know how many successes we had, but we do have our sample size, 1721. We know our sample proportion P hat, that's 0.159. And our number of successes we don't know. So we need one of the gray boxes filled in, essentially. Our confidence level here is different. It's 0.95. So we want to make sure that we put 0.95 in and hit enter. Notice that when I hit enter, that's when the number changes. If I just keep it at 0.95 and I don't hit enter, my values are still from the 0.9 confidence level. So I've got to make sure I hit enter. And then notice some things. We have our P hat here that matches the P hat we put in. We have our new critical value for Z, 1.96. We'll see that one for the 95% confidence intervals for proportions. It's always 1.96. And then we start calculating the pieces of our margin of error. The square root piece, multiply the square root times the critical value, and then we get our confidence interval, 0.1417 and 0.1762. So just like before, I'm going to grab this screenshot and put it over here so we have it. Shrink it a little bit so it's not so big, and we end up with the values that we need right here in our confidence interval. So for number 3, we get 0.1417 would go 0.142 less than P less than 0.176. And then we can say the true proportion of people who purchase the religious books from a used bookstore is between 14.2% and 17.6% with 95% confidence. We could also word this very similarly to the previous problem. We are 95% confident that the true proportion of people who purchase religious books from a used bookstore is between 14.2% and 17.6%. Does this mean that the true proportion of people cannot be 10% or 20%? No, that's not what this is saying. This is saying that if I take 100 samples, 100 surveys, and I form a confidence interval for each one of these surveys, 95% of the surveys' confidence intervals will have the true population proportion in it, and 5 won't. There's a possibility, but it's very small, that the true proportion could be less than 14.2% or greater than 17.6%. There's a possibility that this particular sample does not capture the true proportion in the confidence interval. The thing to keep in mind is the population proportion, that true proportion that they're talking about, is a fixed number based on the whole population of people. These confidence intervals that we create and the samples that we create vary depending on what values we get. If we get a different sample, we create a different confidence interval. The idea here is we're pretty confident that the confidence interval has the true proportion in it. Let's take a look at the next problem. It has been reported that 20.4% of incoming freshmen indicate they will major in business or related field. A random sample of 400 incoming college freshmen was asked their preference, and 95 replied they were considering business as a major. Estimate the true proportion of freshman business majors with 98% confidence. Does your interval contain 20.4? So here, it's been reported. This is a possible P proportion. Random sample of there's N, 95, there's X, 98 is our confidence level. So let's go back to our template and put these numbers in. I don't know N. This time I don't know P hat. I have the number of successes, 95, and the total, 400. And my confidence interval this time is 0.98. It's a bigger confidence. We create a bigger interval because our critical value, 2.33, is a bigger number. So our critical value gets bigger with our higher confidence level. It pushes our confidence interval out. And we end up here with 18.8% to 28.7%. So let's write. I will first come up here and grab the screenshot and put it in here so we have it. And we have our confidence interval there. Let's write it out here. So our confidence interval for number 4 was 0.188 to 0.2869, we'll round up to 287. We are 98% confident. The true proportion of freshman business majors is between 18.8% and 28.7%, and our interval does contain 20.4%. What this means ultimately is that my sample is evidence to support this reported percentage of 20.4%. Since 20.4% is inside this interval, my sample that created this interval supports that population proportion value. This idea will become important to us when we move into hypothesis tests in the next chapter. The last part of this section in 7.4 talks about minimum sample size needed. So instead of looking at, I create a sample, I gather a sample, and I form a confidence interval, this time we flip it around. If I want a confidence interval that has this margin of error, then how big of a sample do I need to take to get that? So we'll look at that in the next lesson.